So again, the domain is all real numbers. Smooth, continuous curve. The power function, f of x equals a times x to the n power. If it's an even degree, it can be symmetric with respect to the y-axis. An odd degree, symmetric with respect to the origin. Those are things to look for to begin with. So let's look at some different aspects of a polynomial function, because I'm going to be having you work through graphing a polynomial function step by step. And one of the first things I want to have you look at is the end behavior. First of all, when we have f of x equals a times x to the n, then if n is even, we have two aspects. Either the coefficient a is greater than 0 or less than 0. Or if n is odd, again we have two situations. A is greater than 0 or a is less than 0. So let's take a look at the n behavior based on n being odd or even and a being greater or less than 0. If we have a is greater than 0, the n behavior is going to be rising to the left and rising to the right. If n is even and the coefficient, a, the leading coefficient, is less than 0, then we have it falling left and right. If n is odd and the leading coefficient a is greater than 0, then we're going to have it rises to the right and it's going to fall to the left. If n is odd but a is less than 0, then we're going to have it rise, it rises to the left, and it falls to the right. Okay, the next aspect that I want to have you look at is if you have a value a is less than b, and f of a and f of b have opposite signs. One is positive, one's negative. Then it knows, then we know, there is at least one number c that lies between a and b for which f of c equals 0. And that's the intermediate value theorem. All right, so here are the steps that we're going to follow in order to graph a polynomial function. 1, we're going to take a look at that n behavior. 2, we're going to find the real zeros or the roots or the solutions or the points where it touches or crosses the x-axis. The y-intercept, where it crosses the y-axis. We're going to determine the signs of f of x, which is going to determine the turning points. And if we have f of x equals a to the n power, we're going to have n minus 1 turning points. The multiplicity, if I have a parenthesis, for example, it might be x minus 1 taken to the m power. That means I have two factors like that, x minus 1 times x minus 1. If m, the power, is odd, then it's going to cross the x-axis at that point. If m is even, x minus 1, for example, to the second power, it's not going to cross, it's just going to touch at the x-axis, but not cross the x-axis. So these are all aspects of a polynomial function that we need to take a look at as we're doing each problem. Okay, I'm going to start out with f of x equals x squared plus 3. So the degree of this polynomial is 2. N minus 1 or 2 minus 1, it has one turning point. So what's the end behavior? Because we have x squared, the n value is even, and the leading coefficient is 1, which is greater than 0. So we have 2 is even, the n value. The leading coefficient 1 is greater than 0. Then I know that the n behavior is going to rise to the right and left. So at least I want to think about that first. The next, we need some real zeros. Now, if I take f of x and equals x squared plus 3 and set x squared plus 3 equal to 0, and I solve, I get x squared equals negative 3. Now, there is no real number that I can take and square and get a negative. Therefore, it means that there are no real zeros in this problem. Now, let's look for the y-intercept. Where the graph crosses the y-axis, it's also where x is equal to 0. So I have f of x, or f of 0, is equal to 0 squared plus 3. In other words, the y-intercept is equal to 3. It's where it's going to cross the y-axis. If I put in f of negative x, remember we practiced this before, and I have negative x quantity squared plus 3 is x squared plus 3. That means it has y-axis symmetry. And it has at most one turning point, because n minus 1, or the degree 2 minus 1, it's going to have one turning point. So what does this graph look like? Well, we're only sketching the graph. We don't have an awful lot to refer to. We don't have a root or a solution where it touches or crosses the x-axis. We have a y-intercept of 3, and I know that it's going to be symmetric on either side of the y-axis. We already did transformations. This should look familiar to you, that what we're getting here is this. And that's consistent with the fact that there are no real zeros. That is, it's not going to touch or cross the y-axis. So it rises right and left. It has no real zeros. It crosses the y-axis at 3. And it has one turning point here, actually at 0, 3. So I have f of x equals x minus 1 quantity squared times x plus 3 times x minus 4. Actually, I have the one that I have on the board as well. So if I was to expand all of this, x minus 1 times itself, times x plus 3 times x plus 4, this is going to be a polynomial function of degree 4. Stop this for a second. This is that I know this is of degree 4. 4 being even. So I have n is equal to 4. It's even. The leading coefficient is 1, which is greater than 0. So again, I know that it's going to rise to the right and left as the end behavior. Next, I need the real zeros. Now that's easy since this is already in factored form. I have x minus 1 gives me a real zero at positive 1. X plus 3 equals 0 gives me a real 0 at negative 3. And x minus 4 equals 0 gives me a real 0 at 4. So the real zeros are -3, 1, and 4. Now, I multiplied all of this out. So I've already multiplied out x minus 1 quantity squared, then I multiplied x plus 3 times x minus 4, and then I multiplied everything out and simplified. So I have f of x equals x to the 4th minus 3x to the 3rd minus 9x squared plus 23x minus 12. So if when I want to find the y-intercept, I want to let x be equal to 0. So that gives me a y-intercept of -12. So I know it's going to, down here at -12, I'm going to have the point 0, -12 down here as where it crosses the y-axis. Now I want to determine the signs. So it divides the number line into 4 regions. -infinity to -3, -3 to +1, 1 to 4, 4 to infinity. So what I want to do now is to take a look at picking a point in each of those sections, and I don't need the value of f of x at that point, I just need to know if it's positive or negative. So the first thing I'm going to do is, let's say I pick -4. Let's go back up to the original. If I put -4 and -1 in here, I get a negative. Then if I put -4 in here, -4 plus 3 is negative, and here -4 and -4 is negative. So I'm getting a negative times a negative, -4, okay. Oh, I'm sorry. This quantity was squared. So this was -5 squared, which was going to be positive times negative times negative. So I'm getting a positive times a negative times a negative. So this region over here is going to be positive. Now I want to take a value in the next region. Let's say I pick where x is equal to -1. So I have -1 and -1 is -2, but quantity squared will be positive. So that first is positive. Then I'm putting in -1 plus 3 is positive. And then I'm putting -1 and -4, which is -5, which is negative. So a positive times a negative, positive times a positive times a negative is going to give you a negative in this region. Then let's say I pick a value in here of, let's say, 2. 2 minus 1 is 1. 1 squared is positive. Then 2 plus 3 is 5, which is positive. And then 2 minus 4 is negative. So a positive times a positive times a negative is going to make this region negative. And then let's say in the last region I pick 5, for example. 5 minus 1 is 4. 4 squared is positive. 5 plus 3 is 8, which is positive. And 5 minus 4 is 1, which is positive. And positive times positive times positive is positive for this region. So what that helps you with is to determine what's happening when you graph it. I know that it's going to rise from -3 to the left, and it's going to rise from +4. So what's happening in between? And this is only a sketch of what's happening here. So that I know I'm going to get a value of where 0, -12. So I know that this is going to come down, and then it has to come back up. And then I know it's going to only, because of the multiplicity here of taking m being an even value here, then it's only going to touch at 1. And then it's going to turn and go this way. Now I don't need to figure out what those values, what this value is here, although I can. Between a positive 1 and positive 4, I can pick values by the intermediate value theorem and figure out that value. But I know that I'm going to have at most 3 turning points because the degree was 4, 4 minus 1 is 3, but because of the multiplicity, x minus 1 to the second power, it's only going to touch the graph at 1. It's not going to cross it.